This is problem 11.5.6. It's an expected value problem, and the question is, or they're telling us, suppose it costs $15 to roll a pair of dice. You get paid $2 times the sum of the numbers that appear on the dice. What is the expected payoff, and then is it a fair game? So the first thing that we need to do is calculate the probabilities for each of these possible outcomes. And we first of all need to think about the possible outcomes. Okay, so what we're doing is we're summing each of the dice, the numbers on the dice after we roll them. Okay, so let's think about the possible sums. So you have two six-sided dice. The smallest sum that you could get is a 1 and a 1, which would be a 2. And so I'm getting that with 1 plus 1. And over here I'm going to keep track of the number of ways that this can happen. Okay, so there's only one way for us to get a sum of 2, and that's with 1 plus 1. We could get a sum of 3, and that could be done with a 1 plus a 2 or a 2 plus a 1. And so there's actually two ways to roll a sum of 3. And then you would just continue this for the sums. For the 4, we could roll a 1 plus a 3, or a 3 plus a 1, or also a 2 plus a 2 would give us a 4. So there's 3 ways to roll a sum of 4. Okay, and you can continue with this. I'm just going to go ahead and tell you the values with 5. There would actually be 4 ways. So that would be a 1 and a 4, a 4 and a 1, a 2 and a 3, and a 3 and a 2. With 6, there are 5 ways. With 7, there are 6 ways. And then with 8, we start to go back down. There's 5 ways. And then with 9, there are 4 ways. And with 10, there's going to be 3 ways. With 11, there's 2 ways. And with 12, there's 1 way. Okay. All right. Now, the reason that we need to know the number of ways that this can happen is because we need to calculate the probabilities for each of these sums. Okay, and that's because we need to remember that the expected value is this right here. We take a look at the possible outcome and we multiply it by the probability of that outcome. And we're going to keep doing that until we hit the end of whatever it is that we're trying to sum. Okay, so this right here, this a sub 1, is just representing the first possible outcome. So this is what that is holding space for. And then this is the probability of that outcome. Okay, so to calculate the expected value, we need to know the possible outcomes. So we see that there are possible outcomes of sums of 2 through 12, and then we need to know the probability of each of those. Okay, and in this particular problem, we're also going to need to multiply by the fact that we're getting paid $2 by, you're multiplying $2 by the sum. So that will come into our possible outcome there. Okay, so remember that a probability is the desired over the total. And each of these number of ways are desired situations for these particular sums. The total is going to be 36. So there's 36 different ways that you can roll a sum, that you can basically roll 2 dice and get numbers. And I'm getting that just from the basic counting law of 6 choices for the first dice, 6 choices for the second dice. So there are 36 possibilities for rolling 2 dice. Okay, so let's take a look at the sum of 2. We're going to put this all together into this, but I just want to do one of these first. So the sum of 2 has a probability of occurring of 1 over 36. And that's from here. So a sum of 2 has one way. There's one way that we can do it, and there's 36 possible outcomes. So desired over total, 1 over 36. We need to multiply this by the actual possible outcome, which is the 2. And then we also need to multiply it by the $2. And this right here represents this value, this first set for the sum of 2. And so then we're going to do that for each of these. Okay, so it's going to end up looking like this. Our expected value, this is actually going to take a couple of lines because it's going to be kind of long. So we've got the outcome of 2, a 1 in 36 chance, and we're multiplying by $2. I'm going to go ahead and drop the dollar sign for now. Then we've got an outcome of 3. The outcome of 3 has 2 ways that it could occur, so the probability is 2 out of 36, and we're multiplying that by $2. And then the outcome of 4 has a probability of 3 out of 36 times 2. The outcome of 5 has a probability of 4 out of 36 times 2. The outcome of 6 is 5 out of 36 times 2. And 7 is 6 out of 36 times 2. And we'll just keep doing this here. The outcome of 8, and remember where I'm getting those top numbers are these right here are our desired ways that we can actually get these. So for the 8, it's 5 out of 36 times 2. The 9, whoops, well, just leave that there. We'll just call it 9 over 1. The 9 has 4 over 36 times 2. 10 is 3 over 36 times 2. And 11, 2 over 36 times 2. And the 12 is 1 in a 36 chance and times 2. Okay, so we actually need to calculate that, and I think the easiest way to calculate this is to actually, all of these have a denominator of 36, so if we just multiply the numerator straight across and then add those, then we can divide by 36 at the end. So if I do that here, this first one, multiply straight across, we get 4 in the numerators. Here we get 6 times 2, so 12. This is 12 times 2 is 24. This is going to be 40. This is 60. This is 84. This is 80. This is 72 and 60, 44, and 24. Okay, and that's all over 36. All right, so if we add those numerators, I believe you end up getting 504 over 36. And if you simplify that, you get 14, and this is dollars. All right, so $14 would be the expected payoff here for this game. And then they also asked if this is a fair game, and it's not a fair game. And the reason it's not a fair game is they're asking you to pay $15 to play the game. So the cost to roll the dice is $15. Anytime your expected payoff is less than what you're paying to play the game, then it's not fair. So it needs to break even in order for it to be fair. Okay, so that would be it for this problem.